I want them to achieve mastery over our standards. But I think, and my vision has very much changed from last year. Last year I was like, I want them to understand, okay, this is like their mastery. They've mastered this content. They understand the material and they've been able to apply it. But this year I've really tacked on like this idea, and we have it on the board over here, that scientists are like cooperative, persistent, innovative, and that they can like have these critical thinking skills and like apply them to different situations. And so I've really catered now my assessments also to show that like, okay, we can understand these data tables and the graphs and how the information applies. And so we also incorporate that into class, and so that those types of things also show up on the mastery because they're assessed that way. So I really care about developing their critical thinking and their just ability to like look at the world analytically and question things. Mm-hmm. After working at the academic center and doing all of the tutoring after school, like across the board and just not even in my classroom, I've noticed that students can really like regurgitate material, and that they can look at material and yeah, they can solve a problem or they can answer a question. But when a new question is posed to them, something that they might not know, they're often like scared to attempt the problem, or they're not sure how to like move on if it doesn't exactly follow a set of rules. And so I think that's like my biggest goal, and what I want them to walk away with is like this ability to have this knowledge that they've gathered, but to be able to solve other problems if they're not exactly the same. How can you look at something and then solve a completely like different problem but still have the same concepts are in tow? How can you change around things and ask and answer questions? We started off looking at like these infographics and looking to see like how percentages can be used in relaying information and how important they are, and looking at, okay, this is the part of an entire thing and how they're relative and how they easily convey information. And so we go into the standard, which is, okay, what's the percent composition of this element in an overall compound? But then what we're going to explore in the lab is, okay, well, what does this mean if I'm talking about soda and productions of different things? How can I apply this? Why is this important as like a consumer or as a scientist or like as someone in industry? Like, what does it mean to know, and why is it important to know that this, like the composition of a certain element or a certain substance in an overall compound? And so that's like what we'll get by the end. Today we're going to talk about something called percent composition. And you already have the definition on your sheet, but we're going to be looking at, okay, what is the percentage by mass of each element in a compound? Okay? So what's the percentage by mass of each element in a compound? So if you remember, I put this up when we were talking about molar mass, right? So here we're looking at water. I have 2 hydrogen atoms, and what's the molar mass of each hydrogen atom? 1.01. Good, and the oxygen 16. So what's the total molar mass here? 18.02 grams per mole, right? Well, if I'm talking about my water molecule here, do you think that hydrogen or oxygen is going to make up a bigger percentage of the mass of this compound? We're looking at oxygen. Oxygen. Why oxygen, Jasmine?
Because it has a bigger molar mass than hydrogen does.
Now, what's this number that we just calculated? Good. It's the molar mass of the carbon dioxide molecule. So now we know the mass due to carbon, which is 12.01 grams, the mass of oxygen, which is 32 of all oxygen in the compound, and then our total mass is 44.01 grams, okay? So now we can calculate the percent of each element. So how do I calculate the percent of carbon in this compound? Yeah?
12 over, or 12.01 over 44.01.
12.01, which is the mass of the carbon, divided by the total mass, which is 44.01, times 100, and what's the percentage of carbon that we get? What's the percent? 27.29%. Good. What's the mass due to oxygen? 72.71% oxygen. And what's the very last step now that we know the percentage of each? add them both together and what to check the work and what percentage do we get in total? Exactly 100% this time.
We have to do it all by one.
And we have to weigh all of them. All of them. I thought just one. We did one of each, then we have to do all.
Okay.
So where do you put that in?
That's what we use to divide by the total mass.
So
So you have to get each one of these, and remember you have to divide it.
So you want to make sure that
It's time to divide it.
Oh, okay. It's supposed to equal 100.
Yeah, what'd you find out?
It doesn't equal 100.
What did you get as your total mass at the end?
97.
Okay, how did you figure out your mass of each component?
5 divided by 97.
Well, how did you measure the mass of each component? It's like, how do you figure out the mass of the starburst?
Individually.
Press tear, put the cup on there, then press tear, and then put each stuff. And what we didn't do is that we forgot
Get all of the ones.
no, we gotta multiply. We have 2 of these, 3 of these. No, 3 of these actually. 2 of these.
But, so if you think about when we talked about the molecule of water, right? When we calculated the percent of hydrogen, we counted both atoms of hydrogen, right? Because it's the mass of all of the atoms of hydrogen, right?
Oh, so we just multiply. Once we get this answer, then we just multiply
You're
it by
supposed
2.
to multiply it times this and then do it.
How's it going? How did you figure out the percent of total chocolate? Okay, what's another way that you could have done it?
Minus the other ones.
What do you mean?
Take away all the other percentiles. Add them all never mind. Add all the percents up and then subtract all the ones that are on.
My name is Destiny Lockhart. I am a junior here at CVPA.
My name is Shalisa Miller, and I am a junior at CVP.
My name is Latia Jones, and I'm a junior at CVPA. I like the way Ms. Neumann teach. I got a very good, she explained it very well. So where I just get everything that I just take in everything that she teach.
We learn something every day. It's not a day that we don't.
Yeah.
And she make it fun. She make learning very fun. So.
Cool. Have you guys always liked science?
No. No.
Not until I got here. I like chemistry. Always go for gold.
Go for gold. Can you tell me about what that means?
Mastery.
She always wants you
To
to
master
master
of what we do.
80% of what we do in the
Every
class.
test or quiz that we
test or
take.
quiz.
And our name get put up on the board.
That means that she understands that you know what you're talking about.
My name is Artisha Strong. I'm a junior at Central BPA. When you get platinum on this Neumann test, that means you got an A. When you get gold, that means you got a B. And when you get silver, that means you got a C. And our average is to get gold, which is the 80%, because she wants all her students to pass with an 80% in her class. That means you have mastered and understand everything that she has went over during class. Well, I like chemistry because I plan on going to engineer field, medical, where you have to measure everything. And so therefore you have to know what you're measuring, how many atoms in the substance and stuff like that. So it helps out a lot. My classes help because everybody works as a team, and obviously when you don't get something right, the next person does come behind and they correct you. And you just learn from that person, and if you don't understand, you sit back and you watch until you're able to understand.
So your classmates help you understand?
Yes, and sometimes I might not get it, so Cody will probably come around, or either Taylor sometimes will just come around and help me.